To Arihant Online Academy, and here in this session we will discuss about the AVL trees. So we will discuss this tree from very basics, and then we will discuss that what kind of problems in this trees may occur and how to resolve that problem using several techniques. Then we will discuss several questions that is asked from AVL trees in GATE exam, right? So guys, watch this video until the end, because the initial session of this video might consisted of some theoretical points and might consisted of some points which you would need to learn, because these points are very essential in order to get the complete concepts right very clearly. That's why please have patience for the couple of minutes, and after that you will get complete knowledge of the AVL tree, right? So here we are starting from the very basics. Now if we talk about AVL trees, then basically in AVL trees, it is based, or it is named because of three computer scientists, that is Adelson, Walski and Landis. Basically you can also say that it is a height balanced binary search tree. Basically height balanced binary search tree. So the important point, that is point number one, is AVL tree follows properties of binary search tree. Now what are the properties of binary search tree? Basically for AVL trees you must know the basics of BST. So in BST, suppose a node is there, then if in that node, if suppose 15 is this node, then if the new node is coming somewhat less than 15 like 12, then you have to add that node on the left side, because it is the property of BST that whatever the lesser elements, or the element or the node that have less amount or less weight than the node address, then you have to keep it into the left subtree. But if you get the node weight is somewhat high than your root node, that is suppose 20 is the new node, right, then you have to add that node in the right side. So in left subtree you will add the nodes which are less than your root trees, and in right subtree you have to add the nodes which are higher than your root node, right? Here 12 is less than 15 and 20 is greater than 15, right? So it is the very basic of the BST. Now the next question, next point here is balanced factor should be updated every time whenever we insert a new node to it. So whenever we will insert a new node to it, we have to keep in our mind that balance factor should be maintained. Now what is the balance factor? So if we talk about AVL trees, in AVL trees, balance factor is very important. The balance factor is nothing but height of left subtree minus height of right subtree should be less than or equals to 1, or it should neither not be greater than 1 and it should not be less than minus 1. It should not be less than minus 1 and it should not be greater than 1. So if we talk about this, then we will see some of the examples of the trees from which how to calculate balance factor will be clear to you. Now the next point here is, if any node have imbalance, then we have to apply rotation technique to make it balance. Now what are these points? Let's discuss this with the examples. Now here if you will see that tree 1 is there. Now whether it is AVL tree or not, just apply balance factor. Now the right subtree, if you will see that left subtree, height of left subtree is 0, and here height of right subtree is also 0, because no node is on the left side as well as no node is on the right hand side. That is why you can say that balance factor of this node is 0 minus 0, that is 0. So the balance factor of this tree is 0, which is less than 1. So you can say that it is a AVL tree. Now if you will see the tree 2, then if you will apply balance factor, then if you will apply balance factor, then height of left subtree is 1 minus height of right subtree, nothing is there in the right side, so 1 minus 0 is 1. So balance factor of this node is 1, and balance factor of this node is, basically this is a leaf node, so the leaf node's balance factor is always 0. This is a leaf node and leaf node's balance factor is always 0. So if you will observe the balance factor of both the nodes, which is 0 and 1, which is less than or equals to 1, so it is also following AVL tree's balance factor property. Now if you will observe tree number 3, then height of left subtree, that is 0, minus height of right subtree. Height of right subtree is 1, so 0 minus 1 is 1. So this node consisted of the balance factor 1, and this is the leaf node, so the balance factor of this node is 0. So the balance factor of both these nodes are less than or equals to 1. That is why we can also say that tree number 3 is also a AVL tree. Now if we'll observe tree number 4, then these are the leaf nodes, and the balance factor of these leaf nodes are 0 and 0. And if we'll observe this root node, then this root node is basically consisted of balance factor, that is height of left subtree, that is 1, and height of right subtree, that is 1. 1 minus 1 is 0. So what you can say that the balance factor of this root node is 0, which is less than or equals to 1. That is why this tree number 4 is also a AVL tree. Now if you will see the tree number 5, then this is the leaf node, so this is the leaf node, so its balance factor is 0, and this is also tree leaf node, so its balance factor is also 0. Now if you will talk about this node, then height of left subtree is 1 minus height of right subtree. In right side nothing is there, so 1 minus 0 is nothing but 1. That is why you can say that the balance factor of this node is 1. Now if we talk about balance factor of this root node, then height of left subtree, height of left subtree is 1 and 1 2 minus height of right subtree, height of right subtree is 1, so 2 minus 1, 2 minus 1 equals to 1. So if we talk about the balance factor of all nodes, then this node contains balance factor 0, this node is also 0, this node balance factor is 1, and this node's balance factor is also 1. So all nodes consisted of balance factor less than or equals to 1. So this tree 5, it is also a AVL tree. Now if we talk about tree number 6, then this is a leaf node, so the balance factor of this node is 0. And if we talk about this node, then balance factor of this node is height of left subtree, that is 1, minus height of right subtree, that is 0, nothing is on the right side of that, so balance factor of this node is 1. So balance factor of this node is 1. Now if we talk about this node, then balance factor of this node is nothing but height of left subtree. Left side two nodes are there, 1 and 2, and on the right side no, nothing is there, so balance factor of this node is 2 minus 0, that is 2. Now 2 is greater than 1, so it is not following property of AVL, so it is not a AVL tree. It is not a AVL tree. So how to make this tree as a AVL tree, we will see couple of minutes after. But if here you can clearly observe that because of this node, it is consisted of the balance factor greater than 1, which is not obeying the property of balance factor property of AVL trees. That is why we can say that this is not a AVL tree. Similarly, if you will observe in the tree number 7, this is the leaf node, and this leaf node consisted of the balance factor 0, because all leaf nodes contains balance factor as a 0. If you will observe this node, then the height of left subtree, that is 0, minus height of right subtree, that is 1, and 0 minus 1 you are getting is minus 1. So no problem, your height should be either 0, 1 or minus 1, nothing else than that. So up till that, here it is following the property of AVL. But if you will apply the property of the balance factor on the this root node, then height of left subtree is 0 minus height of right subtree 1 and 2. 0 minus 2 is minus 2. So basically if you will observe minus 2, then minus 2 is less than minus 1, so your balance factor should be only 0, 1 or minus 1, nothing else than that. If not, if your balance factor is other than this, then you can surely say that it is not following AVL tree property, so it is also not a AVL tree property. So basically I hope up till now you can understand which tree are under AVL tree and which tree are not in AVL tree, right? Now let's see how to solve or how to resolve this tree and how to construct this tree into AVL tree format, right? So basically for that we use rotation techniques. So what are rotation techniques? So whenever you are applying balance factor on a tree, and if balance factor are such that, suppose this is the binary tree, because 70 is the greatest from 50 and 30, so suppose 70 is your first node, then 70 is this, 50 is this, and 30 is this. So if you will calculate balance factor of this node, it is a leaf node, so balance factor of this is 0. Balance factor of this node is 1, that is height of left subtree minus right subtree, that is 1. And balance factor of this 70, that is 2 minus 1. 2 minus 1 is 2 minus 0, because on right side nothing is there, so 2. So these root nodes have balance factor 2, which is greater than 1. So this is not a AVL tree. Why it is not a AVL tree? Because of LL imbalance. LL imbalance is left imbalance, because both are on left side. It is left imbalance. So how to convert LL imbalance into AVL tree? So it is a rotation technique. In this rotation technique, we just need to take a right rotation. So in right rotation, what we will do? We will make the middle. We will make the middle node as a parent node. So we will make middle node, that is 50, as a parent node, and the 30 will be its left subtree, because it is less than 50, and 70 would be its right child. Why? Because it is greater than 70, because we are applying properties of BST, as well as we are following properties of balanced factor, right? So that is why we can say that uh, by combining BST plus balance factor, it will follow our properties of AVL. Now the 50, 30, 70, this tree which is not a AVL tree is converted into AVL tree. So this is AVL tree. So this is the LL imbalance. So whenever we will construct our tree, and if we got such situation, then from that situation we will solve this technique by using LL imbalance rotation technique, right? Now next is RR imbalance. What is RR imbalance? Suppose in meanwhile construction of the BST, in construction of the AVL tree, we got situations such like that, or we are getting tree such like that, where both nodes are making RR imbalance, right? So in such condition, what we will do? We will make middle element, or the middle node, that is this node, as a parent node, and we will make 90 as a right 90 as a left child. Why 90 as a left subchild? Because its weight is less than 100, because we are following property of BST as well. So it is 90, and on right side we will place 110, because we are following BST's property as well. So what we do in RR imbalance, we just need to take a left turn. We just need to rotate the tree via left. You can see here. Whereas in LL imbalance, what we did, we take a right turn. We take a right turn. You can also say that we just here coming to clockwise, and here in RR imbalance we are coming to anti-clockwise, right? So it is the resolution of the RR imbalance to make any tree AVL tree. Now if you are getting condition like LR imbalance, LR imbalance is such like this. If you will calculate the balance factor of this node, it is a leaf node, so its balance factor is 0. Now if you will calculate the balance factor of the 50, so here left subtree is nothing, so 0 minus right height of right subtree, that is 1, equals to 1. So no problem until then, until that. Now if you will calculate the balance factor of this not 60, then height of left subtree is 1 2 2 subtracted height of right subtree nothing, so 2 is greater than 1. So this node is creating imbalance. So how this node is creating imbalance? LR, in LR manner, left right manner. So whenever we are getting LR imbalance, so basically LR imbalance have internal two rotation. What it do have? Internal two rotations are here. Internal two rotations are here. So and final tree would be like that. The child node, or the lowest node, that is 55, we have to make that as a parent node, and the middle node, that is the second highest node, we have to make that as a left subchild, and 60 would be its right subchild, because internally two rotations are there, and by following internal two rotations, the final tree would be like that. So 50's weight is less than 55, so it would be placed on the left side of the 55, and 60's weight is greater than 55, so we have placed 60 node on the right of the 55. So this is the LR imbalance resolution from the rotation technique, right? So whenever in construction of AVL tree, if you are finding condition of LR imbalance, then you have to apply this internal rotation techniques and make the child node as a parent node and the lowest node then the parent node on the left subtree and greater than the parent node on the right subtree. So this is the resolution of the LR imbalance. Now if you will see the RL imbalance, that is right left imbalance. So if you will calculate the height factor of this lowest node, so it is leaf node, so its height balance factor is 0, and balance factor of this node is left subtree. Height of left subtree is 1 minus height of right subtree is 0. So 1 minus 0, nothing but 1. No problem until that. Now if we'll calculate the balance factor of this node, that is node number 7, node 70, then height of left subtree is nothing but 0, nothing is there on the left side, and height of right subtree is 1 and 2. So 0 minus 2 is minus 2. So it is something other than 0, 1 or minus 1. So it is also getting imbalance condition. So how to make this condition imbalance? And by using rotation technique, and just make the child node as a parent node again. So 75 is the child node, childest node, or you can say that the grandchild node as a parent node, and lowest than 75, that is 70, make it as a left subchild, and 80 which is greater than 75, make it as a right subchild, because we are following properties of BST as well as balanced factor. So by combining this, we are getting AVL tree. So here also, if you will observe, internal two rotations are there, but the final tree would be look like that. And this is now following AVL tree properties, because balance factor of this node is 0, balance factor of this node is 0, and balance factor of this node is also 0, 1 minus 1, 0. So finally we have converted the imbalance tree into AVL tree. Now there are four techniques you can see here. First is LL imbalance, second is RR imbalance, third is LR imbalance, and fourth is RL imbalance. So LL imbalance basically have one rotation. Internal it have one rotation, and RR imbalance internal also have one rotation, and LR imbalance have internal two rotations, and RL imbalance internally have two rotations. Right. So these are the four rotation techniques which we will apply in construction of our AVL trees. Now let's see some of the question. First we will see some practice question, then we will see the questions which is asked in competitive exams, right? So construct AVL tree with the following nodes. So the nodes are given to us. Okay, nodes are given to us 15, 10, 20, 12, 8, 7 and 30. So initially we took 15 in step 1, and balance factor, it is also leaf node, so balance factor is 0, so no problem. Then we will take new node as a 10. We will place 10 on the left side because its weight is less than 15, so it would be on the left side of that. And if we will calculate balance factor till now, balance factor of this node is 0, and balance factor of this is 1, that is height of left subtree 1 minus height of right subtree, that is 0. 1 minus 0 is 1. So it is also following properties of BST as well as balance factor. So it is also AVL tip till now, no need to correct. Now this node also placed. Now next node is 20. So 20 is greater than 50 is 15. So we have placed 20 on the right subtree, and if you will calculate balance factor of this and this are 0, as these are the leaf nodes, and balance factor of this 15 is height of left subtree, that is 1, minus height of right subtree, that is 1. 1 minus 1 is nothing but 0. So balance factor of this is 0, 0, 0, no problem. They all are following the properties of AVL trees. So 20 we also placed in AVL tree. The next is 12. So after putting 12, 12 is basically less than 15, so on the left side, but it is greater than 10, so on the right side of the 10. So it is following properties of BST. Now check whether the balance factor is following or not. It is leaf node, so balance factor is 0. It is also leaf node, so balance factor is also 0. Now here balance factor of this 10 is left height of left subtree, that is 0 minus 1, that is minus 1. So no problem, your balance factor should be 0, minus 1 or 1, not other than that. So no problem up till that. Now balance factor of this 15 is 1 2 2 minus 1, that is 1. So balance factor of this 1 is, so it is also following properties of AVL tree, so no problem. We have put 12 on the AVL tree. Now we have to put 8 on the AVL tree. So what we will do, up till this tree is here and 8 is less than 15 and less than 10, so we will put 8 here. So what we have did, we have put 8 on the left side of this 8, and we have calculate balance factor of all the nodes. 0 0 0 0. Why here 0? Left height of left subtree 1 minus height of right subtree 1, 1 minus 1 0, and here the height of left subtree is 2 minus height of right subtree is 1, so 2 minus 1 is 1, so no problem up till then. So we also place 10 in the our tree. Then the time to add 7 into the tree. So basically if you will see here, 7 is less than 15, less than 10 and less than 8, so 7 would be something here. So in our next step, what we did, on the left subtree we have put at the 7, but if we put 7 here, then balance factor of this lead node is 0, no problem. Balance factor of this is height of left subtree, that is 1 minus 0 1, no problem. Here balance factor is height of left subtree, that is 2 minus 1 1, no problem. But here balance factor is it is a leaf node, so 0, so no problem, right? And if we talk about balance factor of this root 15, then here it is creating LL imbalance. Why it is creating LL imbalance? Sorry for the disturbance. Here if you will see the left subtree, then on the left subtree if you will observe here, LL imbalance is creating because the balance factor of this root node 15 is height of left subtree, that is 2 0 1 2 3 3 minus height of this right subtree, that is 1, 3 minus 1 is 2, which is other than 0 1 and minus 1. So the here AVL property is not following, and we are getting this imbalance because of the LL, that is left imbalance. So we have discussed earlier that in case of left imbalance, what we have to do, we have to make middle node as a parent node and solve this technique by using. So what we did, we made this 10 root node, 10 as a root node, and 8 would and 7 would be on the left side, and 15 was on the greater than 10, so it would be on the right side, and 10 12 would be on the right side of 12, but it is less than 15. So what we did, we put 12 on the left side of 12 but right side of 10. And here in this step, it is again after checking balance factor, each and every node is following the properties of balance factor, that is AVL tree. Now the last node that is need to place here is 30. So 30 would be greater than 10, greater than 15, greater than 20. So 30 would be here on the rightest side. So if you will see here, check the balance factor of each and every node. Basically check 0, 1 minus 0, 1, 0, 0. Here 0 minus 1, minus 1, no problem. 1 minus 2, minus 1, no problem. Here if you will check 2 minus 3, that is minus 1, no problem. So your balance factor should be 0 1 or minus 1, no problem. So we have created the AVL tree by using the properties of BST plus properties of balanced factor, right? So this is our final AVL tree which we have made by using these nodes. So guys, I hope the concepts of the AVL tree which I have discussed with you are clear to you. The concept of rotation techniques, the concept of height balance factor, and the complete concept of AVL tree, right? So guys, further if you have any kind of confusions, doubts or queries, please comment us, and please subscribe to our YouTube channel, because in our upcoming lectures we will discuss some of the important gate questions, your problems regarding BST AVL trees, and we will also discuss the important questions and important facts about the gate exam and the all competitive exams, as well as we will try to provide you much more updates on this channel, right? So please subscribe to our YouTube channel and press the bell icon button, so that whenever we will upload new content for you in any form, you will get instant updation from our side, right? Thank you so much guys, have a nice day. Jai Hind, Jai Bharat.